Mars, often perceived as a cold and barren planet with a thin atmosphere, has indeed shown evidence of a more dynamic and watery past. The red planet was not always the desolate place we see today. In its ancient history, Mars hosted rivers, seas, and lakes, which were far more turbulent and water-rich than those on Earth. As we delve deeper into the history of Mars, its story becomes even more intriguing. The ancient Mars was believed to have a dense carbon dioxide (CO2) atmosphere that trapped heat and allowed liquid water to flow on its surface. Rivers and seas were a prominent feature of the Martian landscape. However, over billions of years, Mars underwent significant changes. Its weak and unstable magnetic field couldn't protect it from the solar wind, leading to the gradual deterioration of its atmosphere. Water vapor broke down into hydrogen and oxygen, and the lighter gases escaped into space, leaving behind a planet with a thin, cold atmosphere. The remaining water reacted with rocks, causing the planet to rust and form a thin layer of orange dust. To better understand the current state of Mars, scientists have been exploring the planet's depths. At its core, Mars has a large, solid core composed of iron, sulfur, and nickel. Surrounding the core is a mantle about 1–2 kilometers thick, made up of various materials. The Martian crust is quite substantial, averaging about 50 kilometers in depth. These findings highlight the complexity of Mars' geological structure. Mars has been extensively mapped over decades of observation. These maps have revealed various features, including Valles Marineris, an intricate system of canyons and chasms that stretches for thousands of kilometers along the Martian equator. One region of interest within Valles Marineris is Noctis Labyrinthus, a chaotic terrain with deep chasms and steep-edged rifts. This region provides evidence of ancient water erosion and contains minerals that require liquid water to form. As we continue exploring Mars, we reach Coprates Chasma, which is the deepest point in Valles Marineris. It was once a narrow, long-running water lake that may have contained traces of ancient microorganisms. This region is of great scientific value as it offers insights into Mars' geological history. Moving eastward, we arrive at Jezero Crater, a large impact crater with Mount Sharp at its center. The Curiosity rover, which landed here in 2012, has been exploring the crater, providing valuable data about Mars' past climate, the presence of water, and potential organic molecules. Hellas Planitia is indeed one of the most remarkable geological features on Mars. It is one of the largest impact basins not only on Mars but in the entire solar system. This vast, lowland region was formed by a colossal asteroid impact approximately 4 billion years ago, during the early history of the solar system. The impact that created Hellas Planitia was of such immense force that it not only excavated a deep crater but also ejected large volumes of material beyond the crater's boundaries. The result was a sprawling basin with a central depression and an extensive outer rim. The central depression of Hellas Planitia is more than 7 kilometers (4.3 miles) deep, while the entire basin spans over 2,300 kilometers (1,400 miles) in diameter. In its early history, Hellas Planitia was filled with water, forming a vast lake or an inland sea. The presence of water in such a large and deep basin makes it a subject of great interest to planetary scientists. These ancient Martian lakes and seas are crucial in understanding the planet's past and the potential for habitable environments. They also raise questions about the fate of the water that once existed on Mars and whether it played a role in the planet's geological and climatic evolution. Today, Hellas Planitia is characterized by its topographical features and distinct atmospheric conditions. Due to its great depth, the atmospheric pressure within the basin is about twice as high as the global average on Mars. This results in some unique weather phenomena, such as the occasional formation of misty haze, which is not common elsewhere on the planet. During Martian winters, Hellas Planitia becomes entirely covered in frost, appearing as a large bright spot when observed from Earth. The study of Hellas Planitia and other impact basins on Mars provides valuable insights into the planet's history, its geological evolution, and the distribution of water in its past. It also offers a glimpse into the ancient climate and environmental conditions of the red planet, shedding light on its potential for hosting life in the distant past. Jezero Crater is a location of great interest on Mars due to its geological history. Scientists believe that billions of years ago, Jezero Crater contained a lake, making it an ideal site for the search for signs of ancient life. In February 2021, NASA's Perseverance Rover successfully landed in Jezero Crater, beginning its mission to explore the Martian surface. Perseverance is equipped with advanced scientific instruments and cameras to analyze the rocks and soil, helping scientists understand the past conditions on Mars and the potential for ancient microbial life. One of Perseverance's primary objectives is to collect samples from the Martian surface. These samples will be stored on Mars for future missions to collect and return to Earth. By studying these samples in laboratories on Earth, scientists hope to gain a deeper understanding of Mars' geological and environmental history and determine whether life might have existed on the red planet. Additionally, Perseverance is equipped with the Mars helicopter, named Ingenuity, which successfully demonstrated powered, controlled flight in the thin Martian atmosphere. This achievement opens up new possibilities for aerial exploration of Mars in the future. The mission of Perseverance in Jezero Crater represents a significant step in our quest to uncover the mysteries of Mars and, potentially, the origins of life beyond Earth. By studying the ancient lakebed and its surroundings, scientists aim to answer fundamental questions about the habitability of Mars in the past and the potential for life beyond our home planet. Mars has two small moons, Phobos and Deimos, which are fascinating celestial bodies in their own right. Phobos is the larger and closer of the two Martian moons. It orbits Mars at a relatively low altitude, only about 6,000 kilometers, 3,700 miles, above the Martian surface. This close orbit makes Phobos one of the fastest-moving moons in the solar system, as it completes an orbit around Mars in just about 7 hours and 39 minutes. Phobos is gradually losing height due to tidal forces exerted by Mars, and it is expected to eventually disintegrate and impact Mars in the very distant future, likely in tens of millions of years. When that happens, Phobos will break apart and create a ring of debris around Mars before some fragments eventually impact the Martian surface. Deimos, the smaller of the two moons, orbits Mars at a much greater distance than Phobos. It is located at an average distance of about 23,460 kilometers, 14,580 miles, from Mars. Deimos' orbit is also gradually moving away from Mars, and it is predicted that in the future, Deimos will escape the gravitational influence of Mars, becoming an independent object in space. This process may take millions of years, and when it occurs, Deimos will cease to be a Martian moon. Both Phobos and Deimos are irregularly shaped and have heavily cratered surfaces, suggesting their origins as captured asteroids or objects from the asteroid belt. Their unique orbits and eventual fates provide valuable insights into the dynamics of moons and celestial bodies in our solar system. The ongoing and future missions to Mars hold the key to unlocking many mysteries about the red planet and our solar system. Mars, with its diverse geological features and evidence of a watery past, continues to captivate scientists and space enthusiasts alike. Moreover, the potential for human exploration and colonization opens up new possibilities for humanity's future in space. Human missions to Mars not only offer the opportunity to study the planet in greater detail but also pave the way for advancements in technology, robotics, and space travel. The challenges of sending humans to Mars are immense, including long-duration spaceflight, radiation exposure, life support systems, and landing safely on the Martian surface. However, addressing these challenges could lead to innovations that benefit not only space exploration but also life on Earth. Furthermore, Mars serves as a potential stepping stone for future human exploration of the outer solar system and beyond. Studying the red planet's geology, climate, and potential resources could provide valuable insights into the history of our solar system and the potential for extraterrestrial life. As we venture closer to the possibility of human habitation on Mars, ethical and environmental considerations will be paramount. Preserving the Martian environment and ensuring the responsible use of its resources will be essential for sustainable colonization efforts. In essence, the exploration and potential colonization of Mars represent a significant leap for humanity's understanding of the universe and our place within it. It challenges us to push the boundaries of our knowledge, technology, and determination, fostering international collaboration and inspiring future generations of scientists, engineers, and explorers. The Red Planet, with all its mysteries and possibilities, beckons humanity to embark on a remarkable journey of discovery and exploration. Thank you for watching another episode of Space Odyssey. While you are still here, don't forget to like and subscribe.